Hello guys, sorry to be late, but these are the answers for week 7 assignment 7. Okay. I have not made any presentation, but I will directly uh, tell you how I got these answers. Okay. Few of the students also helped me in solving these answers, getting these answers. Okay. uh, in the first question it is saying in statement 1 it is sparse autoencoders introduces information bottleneck by reducing the number of nodes in hidden layer. In sparse autoencoders there can be more number of hidden layers, more number of nodes inside hidden layers. Basically the sparse autoencoders are more intended towards getting features being extracted properly, so they doesn't care that if the total number of nodes inside the hidden layer is smaller than total number of nodes that are present in input layer. Okay, that's why the idea is to encourage network to learn encoding and decoding, which only relies on activating a small number of neurons. So it is correct. Okay, and yeah, it is we have to use this encoding and decoding. Okay, because we have to extract features, so it will help the system to uh, learn much quickly, right? So in this way, so the C option will be correct. Statement 1 is false, and but statement 2 is true. Okay, in the next question, the loss is between the original input and the reconstruction from the noisy version of the input. Okay, and denoising autoencoders can be used as a tool for feature extraction. Every autoencoder is used for feature extraction, so the B option is correct. The loss is between original input. So in denoising autoencoders, what is the structure is that first we will have the input layer. In input layer the data will be fetched, and then we will have a noise generator. It will generate a noise and add some things, some numbers, some random numbers inside the data set to spoil a little bit, not very much but a little bit. Okay, and then it will be passed inside the encoders and decoder section. Okay, so in the after decoding it has to generate the image that is related to the initial input, the original input. Okay, so that the error is being computed via checking the via comparing the input dataset and the final output data that we get after decoding. Okay, so both statement A and statement B are correct, so D option will be the answer. Which of the following encoders must be used corrupted versions of the input? So over here denoising will be there. Okay, denoising design and denoising autoencoders are the same thing. Okay, and here the corrupted version that it is written now, so it is actually adding noise inside the data set. Okay, so that's why D option will be there. Okay, which of the following autoencoders methods are uses a hidden layer with few units of than the input layer? So actually this answer it was being in lecture 31st. Okay, you can see in the beginning after 4 or 5 minutes sir will tell this thing, like oh, there is one design in which the hidden layer has few number of neurons than compared to input and output layers. So and over there he specifically mentioned the name also, so it was under complete design autoencoder, and so here under complete design will be the answer. Okay, which of the following is false about autoencoders? Okay, so autoencoder possesses generalization capabilities. So in generalization capability is in denoise autoencoders, so it will be correct. Second option is autoencoders are best suited for image captioning. You will see all the examples that sir has taken. All of those are image, so that's also correct. Okay, and other different kind of autoencoders are used for different types of tasks. For it, like in denoising, there will be few gaps inside the image, and the after the generation we will get the original image. Okay, so in this way. Now option C, its objective is to minimize the reconstruction loss so that the output is similar to the input. Yeah, it is correct. So it is, yeah, we cannot directly generate the exact output which is compared perfectly matching with the input. Otherwise it is not learning, it will be like overfitting. There should be some error, but they should try to learn to reduce as much as possible. Like error should not be exact zero but tending to zero. That is the reason why we use autoencoders. Why we are wanting to or that autoencoders are tending to zero for errors is because they will perfectly um, learn to create extract features out of the image. That's why it compresses the input into latent space representation and then reconstruct the output from it. So actually autoencoders compresses the input into uh, feature extraction. Okay, latent space is a different thing, and, and that's why D option will be the false one. Okay, in question 6, the value of delta t minus 34 star x t plus 56, delta t delta function, and star being convolution operation. So it is so in this what actually happens is that delta is directly, like I learned it in this way, that it will just directly add it into this. So what will happen is t plus 56 minus 34 will be there, so it will be t plus 22. So C option, x t plus 22. Now impulse response is the output of dash systems due to impulse input applied at time 0. So impulse response can be on both linear and time invariant, so the D option will be there. Okay, in question 8 we can add in both of them, there is no issue. And impulse is like sudden change in the graph. Okay, now in question D, convolution of an input with the system impulse function gives the output of a dash system, fill in the blanks. So in these options, option A is correct. Other option B and option C are invalid because those terms is not used in any of the videos. One is linear time invariant and other one was a linear spatial invariant. So over here linear time invariant will be the correct answer. Okay, over here you can also see linear and time invariants. Okay, so they are also having impulse response, impulse function. Okay, now in question 9, yeah, this is the original, this is noisy, and as I told you earlier that the noisy will be in denoising. Okay, noise. Okay, so option C will be correct. Okay, you don't even have to see other options. In question 10, which of the following is true for contractive autoencoders? Penalizing instances where a small change to the input leads to large change in the encoding space. So in the encoding decoding part, it is similar to neural networks. We have parameters which will be multiplied with the input data. Okay, and it will be further transferred. So it's like a like if you will create a small error or small change in the initial step, that same change will compile up in the other further steps. Okay, so moving to the next layer, the same data when it is moving to the next layer, so the value of all those things will change drastically. Okay, it's like a butterfly effect. So option A will be correct. Large change in input leads to small change in encoding space now, and penalizing instances where a small change will small change no. Okay, I have given you the reason. So option A will be correct. Okay, so these are the answers that I have marked, and they, yeah, and we have a group, WhatsApp group. Over there we discuss it. So you can, I will request you all to join that group also, and I will give you the link of that WhatsApp group. Okay, and once again I'm sorry that I posted this video a little late, but the reason behind is that I am now in my college and I am very busy. Okay, thank you.